Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 2A. Myself, Richa Shah, 2G. Myself, Richa Shah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology, ICICT 2024, London, UK. The ninth International Conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024. And the virtual event is being held through Zoom today and tomorrow, that is the 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes each for the presentations and 2 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you to the session chair. Professor Poonam Relkar, Professor Renkal is currently working as an assistant professor in the Department of Computer Engineering at STESS, Kashibai Navle College of Engineering, Pune, India. She has published 30 plus papers at national and international journals and conferences and authored one book. Her research interests are IoT, Internet of Things, machine learning, security and database management system, and applications. Ma'am, would you like to share anything?
Okay. Good evening, all of you, all the ladies and gentlemen, and all the presenters over here. So best of luck to all of you. I hope you are all have going to present very remarkable paper. So it's a privileges of being session chair over here. So everyone, best of luck, and you can start the session.
Okay. So now I would like to start the presentation. So first and foremost, I'd like to call on Hajar Alvedi. So her paper is titled on a model of smart waste management system to achieve sustainable development goals in Saudi Arabia, supporting Industry 4.0. So please can you share your screen and start your presentation?
Good morning, everyone. Are you seeing my screen?
Yes, ma'am, it's audible.
Okay, I introduce our model of smart waste management system, to achieve sustainable development goals in Saudi Arabia, supporting Industry 4.0. Work by me, Hajar Abdullah Al-Wadi, Dr. Wafa Makadi, and Dr. Halia. Outlines, introduction, and methods and tool, literature review, proposed our model, discussion, conclusion under future work, last one, reference. Introduction. Waste management system is important as waste has various shapes such as solid waste, garage waste, and liquid waste that increase due to population increase, urbanization, and industrialization, and affect the globe.
Sorry to
Saudi
interrupt
Arabia.
you, Hajar, sorry to interrupt you. Your slide is not changing. It's on first slide only.
What about now?
Yes, now it changed.
Okay. Saudi Arabia face significant waste management challenge with of 15 million tons on solid waste generate annually, driven by rapid industrialization, have a population growth rate, and the fast urbanization necessitating of effective waste management solution to support economic growth, environmental protection, and public health. The sustainable smart waste management system contribute to the Saudi Arabia Vision 2030 under the integrated waste management and shifts toward a sustainable development. The current Saudi Arabia management system has following problem. One, waste separation is done manually by workers. Waste collection takes longer to weekly schedule. Collector traveling on congested roads to collect waste. Increased waste generate in Saudi Arabia due to rapid industrialization, high population, development to tourism stocks, and during Al-Hajj and Al-Umrah. Solution proposed smart waste management system, leveraging Industry 4.0 technology, such as the Internet of Things, and the deep learning to achieve sensible aligning with the Saudi Arabia's Vision 2030 and contribute to the sensible development goals. Methods and tool. The theoretical study reviewed the integration of the circular economy practice to data collection. We collect data through professional platform across Saudi Arabia cities, interview and the decision with the relevant and the community members. 3, data analysis. Analyze the collect data to evaluate the development level of current waste management system in Saudi Arabia and identify a challenge for the improvement. 4, identify factor for the Industry 4-based smart waste management model, focusing on the technology accept in the circular economy practice to create a sustainable waste management system. 5, model development based on Industry 4.0 practical incorporating strategy to address the complexity of the waste management system, aligning with the sustainable development goals. Model evaluation. Experts will thoroughly evaluate the proposed model to ensure its effectiveness in the addressing waste management system management challenge. Literature review. We have 2 important literature review, all these in the 2019. The first one, IOP based smart waste bin monitoring and the municipal solid waste management system for smart city. The aims of this paper, one, it will be improve environmental quality leading to the reduced healthy issues. 2, it will reduce the cost and provide an efficient way to use reduce resource. It will be help in reduce traffic categories as well. Nice to you municipal transportation. Place in Najran city of KSA, Saudi Arabia. The result obtained in this study showed that the system of reasonable feature was generation with acceptable accuracy and efficiency. The future dedication of this work are to analyze the numerical result in the terms waste take, route optimized and cost reduce of the system, include the development and the maintenance cost. The second one, a smart waste management system for crowding area, Mecca and Holy City as model in year 2019 aims. The first one is the proposed system will use the sensor technology inside the bin as a lower level to separate the waste into 4 categories. To use the actor at top level to inform the management system to collect the bin. 3, save time and money. Replace Mecca and holy cities like Mina, Arafat, and Muzdalifah, all this in the Saudi Arabia. Result, the concept of the recycling waste is applied inside the bins, not just to the bins that are valid or not yet. The benefits of the recycling will be improve the quality and the human life and economy. Proposed our model. This is our model. We have 5 layers: physical layer, middle layer, middleware layer, application layer, presentation layer, and the network layer. We have in physical layer microcontroller, many sensor. We use here sensor. We when needed a like time or replace smart waste. Middleware layer, we have database data clouding storage or like this. Application present layer, dashboard, business layer, process data, decision making, generate data of dashboard, waste prediction. النتورك الواي فاي اللوروين which one الواي فاي presentation layer السمارت tracker. Proposed our model, proposed smart waste management system architecture. The proposed system feature comprehensive structure consisting of the 5 interconnected layers that give intelligent and effective waste management system. Innovate use of the IT in waste management system. Utilize the Internet of Things technology for smart waste collection and monitoring with the smart bins equipped with the various sensor, reflecting efficient waste management operations. Data-driven decision making use algorithm like SVM and linear regression to optimize waste collection schedule, determine the best route for the waste collection, and predict future waste generate for the predictive management. Comprehensive dashboard for the monitoring and the management feature and the dashboard in the presentation layer that provide the effective and the waste collection works with the real time that enhancing system oversight and the operational efficiency. This discussion. The flowchart model for the system operation will outline the systematic flow of the operation from the sensor data collection with the bins through data analysis and the decision-making process to execution of the waste collection order and the organizing process monitoring ensuring response and the effects waste management system. In our system, a number of the sensor can be used in preparation to the place, time, and the event. The advantage of the proposed architecture utilize multiple bin color for cost effective and manual waste classification aligning with the Saudi Arabian's sustainable development goals. Two, employees adaptive sensor use based on the location, time, and the event decently optimizing for the event heavy area like Riyadh and quieter area like الباحة. Select sensor appropriate for the type of the waste and the system needs, minimizing unnecessary cost. Designing for the implementation across all Saudi Arabia city for the broad applicability. الأدرس 3 main challenge, long collection time, reference routes, event waste accumulation. Conclusion and the future work. Develop a sensible and smart waste management system for Saudi Arabia. The model is based on the extensive literature review and the data from an interview and the survey. It was evaluated with the software quality matrix and the debatable to any city, Saudi city. The result of for insights for the waste management decision making
I'm sorry to interrupt, but more than 10 minutes are done. Just a gentle reminder.
okay. Stockholders. The future work include real world implementation, effectiveness assessment, and exploring future application. Additional research is assisted to enhance waste management efficiency and sustainable. This is our reference. Thank you for your attention.
Okay, question for you, Hajar. Hajar, are you there?
Yes.
So could you elaborate on the role of IoT in the data collection and monitoring aspects of your smart waste management system?
Can you again, please?
Could you elaborate the role of IoT in the data
IoT.
collection and monitoring aspects of your smart waste management system?
We collect our data from a survey and interview and
So which sensors you are using to check that waste management? What is the use of that sensor? What is the name of that sensors?
which sensor?
You are using the sensors to check the waste management, right?
We proposed.
But you are going to use it. Yeah, you are going to use it. Have you studied about all these things? Okay. So next question for you is, how does the integration of your circular economy principle contributes to the sustainability of goal of waste management?
Again, please.
A simple question. Which sustainable development goals you are addressing over here?
Improve our waste management system in Saudi Arabia and make it good because it's traditional in Saudi Arabia.
Okay, why you have chosen the text messaging system as a communication method with the driver, and how does it enhance the operational aspects of the waste collection?
I can't understand you.
You are
How?
considering the text messaging system as a communication method with the driver, right?
Yes.
So why you are choosing that messaging system, that communication method? Is there any other easy method than this?
Because it's faster.
Okay, it's a faster. If no one is able to read this, then what about it? Okay. Which software quality metrics we can use for the evaluation?
Again,
Which software quality metrics use for the evaluation? You have mentioned in the conclusion in the methods part key software quality metrics we can use for the evaluation. So can you give me one example of which software quality metrics we can use for the evaluation?
we can use SPM algorithm and the shortest path algorithm in Jeddah city. It's like a case study.
Okay, good, Hajar. Uh, Now we can continue with the second presenter.
So moving on to the next presentation, I'd like to call upon Harshit Raj to present his paper entitled Advancement in Passenger Flow Optimization in Smart Transport, a Holistic Survey. So Harshit, you may present now.
So good afternoon, everyone. I am Kalp, and with my partner Harshit, we are going to present on the topic advancements in passenger flow optimization and smart transport. Harshit, can you go to the move to the next slide? Yeah. So accurately predicting passenger flow is an increasingly crucial and important problem that is being plagued in academia due to its benefits in managing crowds and potentially enhancing efficiency. So, this paper offers a comprehensive survey of contemporary developments in the field of passenger flow optimization. It mainly focuses on three different approaches, namely ARIMA, traditional machine learning, and deep learning. The study systematically compares and analyzes multiple research papers within the subtopics, and by understanding the insights and identifying the trends and providing critical synthesis, this survey provides an overview of the state of art techniques in passenger flow optimization. Next slide, please. So our presentation contains the introduction, the literature review, and then after that we'll start with the different techniques. So that is the ARIMA, traditional ML, and deep learning. After which we look at the performance differences between each research paper that we have picked up upon, and then possible future work that could be proposed based on it.
Now, passenger congestion has transformed into a major problem that is affecting cities worldwide, significantly impacting public transportation systems and overall the travel experience for millions. This doesn't just lead to frustration, but a major inconvenience for passengers, and at the same time, environmental harm and economical harm to the country. So, passenger flow optimization is a rapidly evolving study within the field of smart transportation industry. It is dedicated to enhancing the movement of passengers through stations, terminals, and other hubs. Driven by the need to mitigate congestion, elevate passenger experience, and maximize the efficiency, the smart transportation helps to better increase the efficiency for us so that it's a win-win situation for both the users and the transportation facilities. We have studied different papers and tried our best to provide a comprehensive summary on the advancements in this field. We have categorized these papers into three different categories. Initially, we'll discuss ARIMA-based technologies, which were pretty common in the 80s and the 90s, and then traditional machine learning techniques, and lastly, deep learning-based techniques. Now, autoaggressive integrated moving average, or ARIMA, is a statistical analysis model that uses time series data to either better understand the data set or to predict future trends. For the first paper by Hemant and Cook, it fits the dataset into by three steps. First is identification, where the initial variable Values are determined by inspecting correlations of the series estimation, where the moving averages are estimated using the least square techniques. And lastly, diagnostic check, where you see how good the fit is determined. Now, seasonality arises when there is presence of predictable and recurring patterns within the data. So Williams and his team use seasonal ARIMA to address this seasonal pattern to predict the time series data better. Now, it performs better due to the fact that traffic is cyclic in nature, and the initial paper did not use that, so it was an improvement. Now, we move on to the second category, which is the traditional machine learning. Now here, the team of Sun used Bayesian network for analysis. So what they did was they employed information obtained from neighboring roads to examine the patterns in the road objects, and then use Bayesian network for analysis by using the joint probability of the cause and effect nodes. This could predict the data both when there was very little data and at the same time when there were large amounts of data. Now, the next improvement that we saw was the use of hybrid models, where SVM was used with wavelet transformation. So the wavelets were used to convert the regular passenger flow data to different frequency components, while Liang and his team proposed a hybrid model using Kalman and Kalman filters. So the Kalman filters are a powerful state space estimation technique that effectively deal with noisy data and provide optimal estimates. So they applied Kalman filters to estimate the state of the passenger flow, and then used the KNN to find historical data patterns that were similar, and try to cluster them together. And lastly, using this clustering method as well, the Park and his team proposed a model called FunFem. So what they did is they basically clustered different metro stations, and then they tried to predict the passenger flow using these stations.
So multiple deep learning models have been developed for passenger flow prediction. And the paper which we picked up, the first paper in deep learning which we picked up, it uses a hybrid architecture for short-term passenger flow prediction. How it does this is by combining a BPNN and an EMD, right? So BPNN is a backpropagation neural network, and EMD is an empirical model decomposition. So an EMD breaks down the original flow data into series of intrinsic mode functions, and these intrinsic mode functions contain different timescale components of data. Now the BPNN then predicts each IMF separately, and then the predicted IMFs are combined to obtain the final prediction of the passenger flow. Meanwhile, the next paper that we picked up proposed a hybrid architecture with two components, an SVM and a DBN. So DBN stands for Deep Belief Network. So DBN will capture a low-dimensional view of passenger flow data and its essential variations and patterns. So, and the features that are extracted by this DBN are then fed onto the SVM, which predicts the passenger flow. The proposed architecture in this paper had good accuracy on complex data, but one of its major drawbacks was it's inflexible due to its simple nature. So there couldn't be any more upgrades that would be able to perform on them. Hence, Zhao and his team proposed an HSTDL net. So a hybrid spatio-temporal deep learning model for short-term flow prediction. Now, in this model, the inbound and the outbound flow data, right? So when a passenger is entering the metro system or exiting, is collected and then passed on to an HSDDL net, which is a combination of a convolutional neural network and LSTM. So this model captures both the spatial and temporal correlations in the passenger flow data. Now, Howe and his team incorporated sequence-to-sequence learning for passenger flow prediction. The term sequence-to-sequence reflects the core functionality of the model. as it takes a sequence of input data and then generates a series of output data, unlike other models, which have a fixed number of inputs and a fixed number of output sizes. This model is split into different components, and a model called encoder first reads the historical passenger flow data. This data is then encoded into the fixed size representation, and then the model called decoder is used to predict the information needed based on the encoded information. Now, a more generic approach was implemented by Xiong, and they investigated the effectiveness of three different deep learning models for passenger flow prediction. These three models were CNN based, LSTM based, and a hybrid of both. Now they found that
Kalp, sorry to interrupt, but I just wanted to tell you that 10 minutes are over. Just a gentle reminder. We'll have to wrap up.
The results on this proved that LSTM and CNN, the combination of both, were a better model approach for higher accuracy. Then Zhang proposed a model with three components again: ResNet, GCN, and LSTM. This model can learn how the passenger flow at one station is related to the passenger flow at another station. And Liu et al. Incorporated aspects of the previous model, and it combined them with other external factors such as the weather condition, the pollution, and if it was a special day, so some festival, something like that.
So this is how the models have performed while testing. The reason for large deviation from the results in few deep learning models that we can see is due to overfitting, which could have been avoided by having a more diverse training data set. So while we look at the models, ARIMA performed well for short-term traffic prediction, but it misses the non-linearities that happen in a regular traffic, while machine learning techniques were promising but need large number of data sets, and neural networks were promising in long-term prediction but neglect past data and can have more improvements in that field. And when we use deep learning's hybrid LSTMs, they showed that they could have a lot of scope, especially when we can include other factors like weather and so on. Now, in conclusion, ARIMA achieved promising results and did the best, but it does not incorporate any non-linear nature of the data set. And combining passenger flow with ML is pretty efficient, but needs a lot of large data sets. And hybrid LSTMs often improve accuracy in deep learning due to its inclusion of short and long-term factors, but they have a lot of computational expense. So the future work that we can have is actually including real-time data and seeing by how much do they differ, or having incorporation of other external factors that can affect it, such as the weather, then having set frame evaluation frameworks so that we can test how different models perform to each other, have adaptable and transferable models so that the data can be transformed from one model to another, and user-centric approaches. So here are references, and we thank you.
Okay, good, Harshit and Kalp. Now my question, am I audible?
Yes.
Yes, ma'am.
Okay. So my question is to you is why did you choose to focus on these three approaches, ARIMA, traditional machine learning, and deep learning? So are there particular strengths or limitation of these approaches that influenced your decision?
So basically, when we were looking at the papers, the best way we thought we could categorize the models is based on these three techniques, is because they all used a bit of all these three models, like, how the first two papers used ARIMA based time series data to predict. So that comes under ARIMA. Then this later
Okay.
on when you use neural networks. And so that's how we categorized.
Okay, so were there any surprising or any unexpected findings in your review of the state of art techniques?
One thing that I did mention in results was we didn't expect such large error in deep learning models because we thought it would be enhanced. But the thing is, this could be a lot of bias due to the testing data set being used, so that the previous models used the training and base used testing data set that were very linear, and just to see how the factors affect deep learning models were tested on a more harsher data sets.
Okay, okay. So what limitations should be considered when interpreting the findings of your study?
We should keep in mind that so for example, right, like each and every approach has different limitation of their own, but we should make sure to not judge a paper based on its how recent it is, right? So as we see, like even the older approaches, which right now, if someone says that we used Arima, it doesn't sound like it's very appealing because it's very old approach, but even that has higher accuracy when you compare to the current deep learning models, even though of course there are some other factors as well, where the newer deep learning models are considering that hey, what is the weather that could affect the traffic, or what is the pollution that could affect. There are all these additional approaches, but when we try to find some application, so if you want to avoid some sort of an accident or some sort of an overfill, then in those scenarios uh, it is good to not ignore the previous aspects as well.
Okay, good. Ma'am, we will start the next.
Yes, ma'am.
Thank you, ma'am.
So next, I'd like to call upon Mr. Koki Matsuno for his paper titled "Estimation of Difference in Work Attitudes by National Character from Physiological Signals." So, sir, could you please present your screen and start your...
Okay. I am sharing my screen. Can you see?
Yes, it's visible.
Yes,
Okay.
yes.
So I will start. Hello, I'm Koki Matsuno from Ritsumeikan University in Japan. The title is Estimation of Differences in Work Attitudes by National Character from Physiological Signals. This is outline of my presentation. First, I briefly share the background of my study, and next, I introduce the proposed method and the experiment. Finally, I will share some results and discussion. Let's get started from the introduction. More and more foreign workers in Japan now. National institution reported that Vietnam is in the first place by nationality and in fourth place in ICT industry. However, there is a problem of low retention of foreign workers. One of, one of the causes of the problem is the mismatch between required work attitudes in Japanese companies and work attitudes of foreign workers. And then I will share some examples of differences between Japanese and Vietnamese people regarding work attitudes from previous study. Japanese people tend to work on related tasks in general, whereas Vietnamese people tend to clarify their individual tasks. In terms of work-life balance, Japanese people prioritize work over family, while Vietnamese people do the opposite. In terms of how they perceive work, the Japanese consider work to be a reason for living, However, Vietnamese tend to consider work as a means of income. From these differences, human resources development, reflecting differences in work attitudes, can be effective. Then let me explain the previous study. Work attitudes are influenced by value about work. There are two main methods of comparing values. The first method uses linguistic means, such as questionnaires or interviews. This method is used in many studies, but has some disadvantages. The second method uses physiological characteristics, such as pupil diameter and heart rate. This method has the advantage that it does not require any voluntary actions from subjects. This study uses a combination of these two methods. In this section, I will describe the proposed method. This is an overview diagram of the method. Briefly, the participants are required to watch videos and physiological signals are recorded during video watching. Differences in psychological changes are detected from physiological signals, and differences in work attitudes are identified. In this experiment, pupil diameter and EDA are recorded. Pupil diameter is measured from eye tracker placed at the bottom of the screen. EDA is measured from wearable sensor attached to the subject's left wrist. In this experiment, subjects are asked to watch some short films. After watching the films, the subjects are asked to answer a descriptive questionnaire for each scene of the video. In this experiment, storytelling videos are selected. Storytelling videos tend to trigger emotional changes in the viewer. In addition, videos with content focused on working situations can present specific work attitudes. Therefore, those videos can pretend. Therefore, those videos can present work attitudes to viewers through the characters. In this study, psychological changes are considered in two aspects. The cognitive aspect indicates attention and concentration, and which is shown as a change in pupil diameter. The emotional aspect indicates like or dislike, and which is shown as a change in EDA. Change finder is applied to EDA diameter and pupil diameter and EDA to detect psychological change points. Finally, the differences in psychological changes are compared to discover differences in work attitudes. For example, look at scene 1. The same psychological changes occur between the groups. So the work attitudes shown in that scene are shared work attitudes. Now look at scene 2 and 3. Different psychological changes have occurred between the groups. The work attitudes shown in those scenes can be unshared work attitudes. By comparing psychological changes between groups in this way, it is possible to estimate differences in work attitudes. Let me now explain the experiment. In this experiment, 15 Japanese and 30 Vietnamese people participated. Two conditions were set for participation in the experiment. The experiment consists of watching videos and then answering questionnaires. This is a description of the videos used in the experiment. Those videos are about environment and social contribution. You can see YouTube links on my paper. In this section, I will show you some results and give discussions. These tables show the things that
So
affect.
just a gentle reminder, 10 minutes are over. So you need to wrap
Okay.
it.
Okay. Cognitive changes in Japanese group and Vietnamese group. The area framed red are common change points for Japanese group, and area framed in green are common change points between Japanese and Vietnamese groups. Originally, more changing points were detected, but now only some parts are shown now. The differences in work attitudes are examined by comparing the questionnaire responses and the change points. The first results show that there is a difference in perceptions of work. Japanese people pursue intrinsic value for work, while Vietnamese people perform work as duties for earning a salary. On the concept of work and salary, we show the same results in the previous study. The second finding in this study is the difference of approach to the difficulties. Japanese people show an attitude of accepting and overcoming difficulties, whereas Vietnamese people try to avoid difficulties as much as possible. The third result shows that the Japanese have a distinctive work style. The Japanese consider working in teams to be more important. These two results are new to this study. The fourth results show that the attitudes toward family and work. Japanese people tend to prioritize work over family, whereas Vietnamese people consider family is essential to work. A fifth result shows that the different attitudes towards overtime work. The Japanese consider overtime work to be necessary and important, whereas Vietnamese believe that it should be avoided. These results are consistent with previous studies. Finally, the
So you'll
results.
have to wrap it up a little bit quickly, please.
Okay. Finally, the results show that they seek approval from different people. Japanese people want many people to understand the importance of their work. However, unlike the Japanese, the Vietnamese want to get understanding from their families. This is the summary. This study proposed a method for estimating differences in work attitudes according to national characters. The results of this study are expected to be utilized in the human resources development of foreign workers in Japanese companies. Thank you for listening.
Okay, good, Koki. You have interesting perspective on addressing the challenges of returning foreign workers in Japan through these psychological signals. Now, my question to you is, what motivated your study to focus on the retention rates of foreign workers in Japan? And how did you identify the gap in understanding the work attitudes between the Japanese and foreign workers?
Oh, the first question is, what is the motivation of study, right?
Right.
Um, the motivation is the f- there is a fact that many foreign workers in Japan, but most foreign workers uh, quit a job soon, and this I think this is a problem. So I focused on this problem. And the second question is, can you repeat it again?
Means, see, here you have observed the difference of works attitudes between Japanese and Vietnamese, right? But is this subject
Yeah.
should be applicable to other nationalities as well?
Uh, yes,
Have
yes.
you did any survey on it?
Um, I know I have to focus on the other nationalities, but in the survey, Vietnamese people is uh, most how can I say, the most highest number of people in Japan is Vietnamese. So I choose Vietnamese and Japanese.
Okay. Now, could you elaborate on the choice of psychological signals such as that pupil diameter and the EDA? How they are indicative of cognitive and emotional changes during video watching? How it will useful to check that pupil diameter and EDA?
Oh, I'm sorry. Can you make the question easier?
See, can you elaborate the choice of your psychological signals? Those two signals you have considered, pupil diameter and the EDA, right?
Yes.
Yes. So, how they are indicative of cognitive and emotional changes during video watching, how they will useful for it.
Yes. Uh, in the cognitive side, um, pupil diameter will change when people focus or um, concentrate on the subject object. So it means when people focus on the content of a video, the pupil diameter will change. So I can show that the subject is focusing on the content. In the same way, if the EDA changes, it means subject emotion is changing.
Okay, ठीक है, good.
Yeah,
You
thank
present.
you.
Now we'll start with the next paper, Richa ma'am.
Yeah.
Thank you so much.
So I wanted to ask, Yibra, are you like able to present this time, or should I ask someone else to present right now?
Yeah,
Yeah,
Richa,
ma'am.
I can present. I will try to share my screen. Otherwise, you will share me the slide already I shared you.
Okay, no problem.
Yeah.
Give me a second. You try to present, or else I'll do it for you. Yeah.
Okay, that's fine.
Let me just give your introduction again. So, we'll be presenting on the paper title AI-driven data center, airflow management, cooling system optimizations. You can start your presentation.
Okay, Richard, can you display the slide I shared with you, please?
Okay, no problem.
Yeah. Because I have some problem with my PC.
Yeah. It started. Give me a second. Yeah.
Okay. So, okay, thanks so much for everyone and for the organizers to give us this opportunity to present our works. So our research paper title is AI-driven data center airflow management and cooling system optimizations within the data centers. So as we know that the data centers are the backbone or the core infrastructure of the ever-increasing digital infrastructure. It houses different types of components. The major components are the IT equipment and the cooling system. And these are the major energy consumers in the data center. So we plan to optimize the cooling system because it maintains and it controls all the thermal conditions within the data center. Can you proceed with the next page, please? Next slide.
Is this slide?
Yeah.
Another one? Yeah.
It's on first slide only.
Yeah, I need the next slide. Yeah.
Yeah, I'll just keep on moving. You tell me, okay, if it's the one, yeah? Is this one fine?
Yeah, it is in the first page. So can I maybe proceed with the next one if you can? Yeah.
Yeah.
Slide 3.
Slide 3, yeah, okay, one second.
Teacher ma'am, first you click on that enable editing option, then only you are able to go to the next slide.
No, I am sharing. I guess my screen isn't like the new one isn't visible to your way. Just share again.
Okay.
It might be because of some internet issue. Wait a second. I was on the slideshow.
No, it is not the slideshow.
Oh, it isn't visible to me.
It's only PPT open.
Oh, okay, wait. I was on the slideshow. I'll do it again. Hi, is it visible now?
No, same first slide only. You click on that enable editing option.
Yeah. Give me a second.
Yeah, that one.
Now you slide to the slideshow.
Is it visible?
Yes, right.
Yeah.
Right.
Thank you.
Okay.
So yeah. I will try to briefly present what our focus on. Efficient airflow and cooling management are crucial for both the economic and environmentally sustainable data center management because this enables or this cooling system ensures the IT reliability and longevity, which means that it maintains the operating condition of the IT systems and it maintains their lifespan. It reduces the downtime and maintenance costs because even 1% of degree Celsius increasing in the data center environment will lead to loss, huge economic loss and environmental impacts. This enables us to prevent the hotspots, improve efficiency, and optimize the performance of the data center operations. However, the conventional solutions or the conventional management tools are inadequate, which are failing to yield optimal solutions. These are the heuristic approach, statistical engineering tools like the CFD. Next slide, please. Sorry. So yeah, the key challenges of the current solutions, the heuristic, statistical, or the traditional engineering tools are one of the challenges is the exponential growth in data center management data and the physical complexity of the data center infrastructure. The sheer number of possible configurations and non-linear system interactions, because the feature we are going to collect from the data center infrastructure are very non-linear and their interaction is very complex. The current solutions are unable to adapt to the dynamic condition because these are reactive solutions, but the data center infrastructure is dynamically changing due to the workloads, which is maybe accessible by different types of enterprise or end users. These solutions are limited with accurate predictive capabilities and computationally expensive. Scalability, static cooling policies, and adapt the challenges within the data center leads to over or under cooling energy and leads to inefficient energy consumption in the cooling system because they are not managing dynamically. Next slide, please, Richard. Thank you. AI-driven data center airflow management and cooling optimizations is the promising technologies that enables us to automate these operations in such types of complex environments. So these methods are ideal for modeling and optimizing the data center airflow and cooling behaviors dynamically without no extensive physical interventions. They learn patterns and relationships of the complex features which are going to collect on these different types of data center infrastructures. These methods rely on the explicit, they are relying without relying on the explicit knowledge, they are by no understanding the physical behaviors of the systems. These technologies can learn the data center behaviors and enables us to automate the infrastructure, specifically with the airflow and cooling management system. They are adaptable, they are accurate predictive analytics, automated optimization, they are adaptive control, preventive maintenance, and scalability with data center dynamics. Because they are learning from the complex features we are going to collect using different types of technologies like IoT and smart onboard sensors. Then by learning from this data, these models can be adaptable in this infrastructure to dynamically control the data center operations. Next slide, please. So our model developments or the proposed AI-driven model developments are, when you see the diagram, this is a diagram we are followed to develop our models in the infrastructure, focusing in the cooling system and supply air flow to the data center. This study explored various models to accurately predict supply airflow patterns and dynamically adjust cooling fan speed, because this cooling fan speed is the controllable variable that enables us to control the operation. We select the very strong machine learning approach and deep learning approach. From the machine learning, we explore the random forest regression model and XGB. From the deep learning, we explore CNN, LSTM, and the hybrid CNN, LSTM deep learning methods. That is the one we proposed at the end. And the actual operations datasets obtained to train this model from high performance computing data center from Italy. 80% of this data was used for training of these models, and 20% of this data was used for validation. And optimization strategies also demonstrated using cooling system fan speed controllable variable using 6 different scenarios. Next slide, please. Reach on next slide. So this is the development framework already. We use it to develop these models. From the data sets, we had the data collected from the data from the high performance computing data center infrastructure. This data includes the energy consumption related data, cooling system related data and the environmental related data. Then we did data engineering and pre-processing on this data. We clean out, we clean and synthesize that data, and we standardize the data. We also did feature engineering. That's because the operation behavior of the data center is multivariate time trace. In time trace, there are different types of covariates which are extracted from the features, which are the temporal features. So we did extract these features. These features was the hours, days, weeks, and months. And we did feature selection because some of the traditional machine learning like RF and XGB are extremely sensitive with the features, with relevant features in order to model the target variable and to perform well. But in the case of deep learning, there is no such types of sensitive dependency on these features because they are learning from the complex features and generating the best fit model. Then next, already we explored these models, the machine learning and deep learning models, and we hypertune those different types of parameters on the training data, and already we validated using the rest of the data to test the model, how it behaves the infrastructure. And then we use the sensitivity analysis. In the sensitivity analysis, already we
10 minutes are almost over. You'll have to wrap up.
Okay. So then we did a sensitivity analysis in order to check that how that model is optimal to predict the supply air patterns using the fan speed controllable variables. Then next slide, please. So these are the simulated results or the experimental results of our model developments. The first table 2, which is already taken from the paper, of course, shows that the model performance evaluation and time complexity index. So we can see that those different types of models, we evaluate them using different types of error evaluation matrix. And from this, the hybrid CNN LSTM is the best model that performs well when we compare with the others and slightly improved from the rest of the deep learning approaches. And in table 3, which is taken from the paper, that demonstrates the sensitivity analysis. We use different types of sensitivity analysis, especially 6 scenarios, by increasing and decreasing the cooling fan speed. This prediction is in every 15 minutes. So in that 15 minutes, we did this sensitivity analysis, and the model slightly improved when the fan speed dropped in that time by 50%. And we can imagine that the temperature range which is recommended in the hyper performance computing data center infrastructure is within 15 up to 20. So based on that, we did a sensitivity analysis and did check that how can it dynamically adjust the temperature within the data centers. Next slide, please. So the current challenges with the AI-driven approach in the sensitive environment is the data quality and availability. The data which are collected from these infrastructures are not that much, the quality is not that much because data are collected in different types of intervals using different types of devices. So it is tedious to do different types of pre-processing in there. The models are non-deterministic produce non-deterministic outputs. The model are very complex and explainability is needed to explain the model why they give us this decision, why they give us this output. So, and to understand the factors behind. Performance, efficiency, and domain expertise collaboration is needed because there are a lot of engineering things in the infrastructure. And the model development, the deployment management, because the infrastructure is, for example, if we have different types of cooling system in that data center, we need to data fusion those different types of for those different types of models, or we have to deploy in these different types of infrastructures, these agents. Next slide, please. So in conclusion, the deep learning methods are ideal for modeling and optimizing the data center airflow and cooling management approach. They showed better performance with reasonable computational time when compared with the traditional one. By simulating the trend, operators can dynamically manage airflow and adjust the fan speed without significant physical intervention. More evaluation is at the end. More evaluation is needed here in say types of things with more data. So for more consistent, to evaluate more consistency of these models. So this is the presentation, of course. Thanks so much, and sorry for the inconvenience.
Okay. Vibra, right?
Yes.
So Vibra, why did you choose to leverage the random forest, XGBoost, CNN, ensemble CNN, LSTM models for this framework?
Yeah, that's a good question, of course. So we did select these methods, the advanced methods, of course, in our, we have different papers. So we extract from that, we have different types of literatures. And these models performed well. At the same time, the deep learning models are very promising technologies that to handle say types of complex environments, because in the data center there are a lot of features which are interacted non-linearly, which is difficult to handle by the traditional machine learning approach. At the same time, they enables us to capture the temporal and the time lengths of those different types of data which are collected from the infrastructure. So based on that, we focused on this deep learning approach, and we compare them with the traditional, some of the traditional approaches, how they are performing over them.
Okay, so what specific metrics were used to evaluate the performance of different machine learning models in predicting supply airflow patterns?
Yeah, we used three evaluation metrics in the time series. There is root mean square error, there is mean average error, and mean square error metrics.
Okay, so in your data set, what features you are considering? Can you give me some example of features you are used in your data set?
Yep, the features we used in our data set from the data center infrastructure is we have cooling parameters like the supply air, the return air, and different types of conditions from the onboard sensor. We have IoT devices which are installed around the cluster. We use it to collect the weather condition data like the humidity and temperature. And we have energy consumption related issues in the IT and cooling systems. And we have the IT load data sets.
Okay. So you have mentioned somewhere scalability with DC dynamics. It
Yeah.
means what? What it exactly?
Yeah.
Scalability with DC dynamics.
Yeah, the scalability is the data center infrastructure is scalable, and its complex is very increasing day to day because of the rapid increase, the ever increasing digital infrastructure. Supports that we need different types of equipments to install in the data center and to install different types of cooling systems. So when this, for example, if today I have one cooling infrastructure, tomorrow I may have 2, 3, 4. This scalability affects the model itself. So in that case, if we don't have the data fusion from those different types of cooling systems, we can't decide that by taking a single cooling system, this much optimal or this much inefficient. So these are the scalability within the data center infrastructure. Of course, we are focusing on that.
Okay, good. We will good presented well. We'll go for the next paper.
Okay, thanks.
So now I'd like to call upon Kenzu for the next presentation titled The Factors Influencing Continuous Intention and Herd Behavior in Social Commerce, Ease of Use in Online Customer Experience. You may please present your screen.
Okay, let me try to share the screen. Have you already seen my shared slide?
Yes,
Okay.
your screen is visible.
Yeah. Let me play from beginning. Good afternoon, Chair and everyone. My presentation topic is the influencing factors of two consumer decisions in social commerce, continuous intention and herd behavior. I'm grateful to be the presenter today on behalf of the other two co-authors, Dr. Caroline Swing-Lin-Tan and Dr. Turan Panwar. Before reporting our study, result and implications, I will start by introducing the research background and relevant literature. First, we target at social commerce. Social commerce is a specific e-commerce type. In traditional e-commerce format, seller offerings are the primary information source. Seller offerings include product images, descriptive text, promoted prices, sound, and sometimes short videos. By comparison, in social commerce, a certain amount of information is provided by the social commerce users, I mean the consumers. This content are called user-generated content or UGC. The percentage of seller-offered information is reduced in social commerce. We selected two of the China's most successful social commerce formats, live streaming commerce and group buying. Live streaming commerce provides real-time sight, sound, and motion to deliver product information, thus enhancing information authenticity and enriching content. During this process, the real-time comments from the other viewers belong to the UGC, of course. Group buying relies on the UGC even more than live streaming commerce. Because of the foundation philosophy of group buying is team purchase discounts. I mean, the more consumers order, the lower prices they can enjoy. As a result, consumers are encouraged to post more content in group buying in order to attract other consumers to participate. The literature on social commerce has emerged quickly in recent years. We can see this figure. Most of these are about live streaming commerce. Compared to live streaming commerce, I counted about 274. The papers about group buying are only 29. Among the existing studies, two theoretical systems are commonly used. One theory stream is associated with a social aspect. For example, social support theory and social impact theory. All theories in this stream are similar due to the same social psychological philosophy. Individuals increasingly undertake behaviors that necessitate interaction and discussion with others. The second stream of theories relates to consumer attitude, referring to the people's easily recalled beliefs about an object, which shapes their opinions or attitudes. There are main three theories about this. One is uses and gratification theory, UNG theory. The second one is stimulus organism response framework, in short, SOR. And then the technology acceptance model, TAM. In our study, we employ SOR framework. Following this framework, determining the stimulus is the key, because all the hypotheses I proposed are developed based on the stimuli factor. In existing social commerce studies, we can see various factors have been examined. To select the appropriate ones, we decided to use controllability to divide the stimulus from the seller's perspective. The bolded factors at here are controllable. For example, website quality and ease of use. The sellers cannot fully control the other factors. For example, the ratings and reviews. So we call these factors as uncontrollable factors. We choose one controllable factors, ease of use. It refers to the easiness sense the consumer believes. One uncontrollable factor, online customer experience, we can see in the center of this figure. This refers to how consumers feel while shopping from the social commerce. Of course, ease of use may be a factor can contribute to the experience the consumer feels. As a result, online customer experience is the organism factor of this model. Continuous interaction and herd behavior are proposed as the responses. Let me introduce their definitions. Continuous intention represents unconscious behavior that becomes part of the frequently repeated activity at the post-acceptance stage. Herd behavior is the herding, but not occur in the animal, but occur in human consumption behavior. Consumers choose to follow others collectively when they trust others based on their incomplete information and situational factors. We adapted the indicators from the existing studies and modified their contents to adapt to the social commerce environment. The 7-point Likert scale is employed for each variable. The cognitive experiential state here in the center of this table relates to the awareness, memory, learning, judgment, or the rational experience, while the affective experiential states concerns hedonic feeling and emotions like fun, playfulness, surprise. A total of 1,299 participants accessed the questionnaire, while 829 of them complete them. Eventually, we used 694 valid respondents. And we can see among these samples, there are slightly more respondents from live streaming commerce than group buying. Based on the radar graph in the right, we can see individual social commerce format shows the similar patterns. First, both of the formats are dominated by the females aged 26 and 41. The percentage of them who use social media daily and online shopping frequency are very close. The individual social commerce format don't have significant differences. As a result, we treat all the samples together and proceed it with partial least squares structural equation modeling. In short, PLS-SEM. We checked the sample's normality and validity of variables composite, reliability, and average variance extracted are above the cutoff value we can see from this table. The sample also passed the discriminant validity check. Because the online customer experience is a higher order construct, therefore, we use a two-stage approach in PLS-SEM. First one, we computed the latent variable scores and incorporated them
Excuse me, just a gentle reminder, 10 minutes are over, so you'll have to wrap it up quickly.
Okay. And then second step, we're linking the new data file with the model and using these latent variables as indicators of the second order construct. The model is valid. And this figure displays the model results from the bootstrapping procedure for 5,000 samples at a significance level of 0.05. We can see at here, only H3, the third hypothesis, is insignificant. All of the other 4 hypotheses are significant. And based on this result, we also found online customer experience is more critical in influencing consumers' decision-making process in social commerce. Based on this, we get the first implication based on the managerial. The social commerce sellers should design relevant marketing strategy to improve consumers' experience. It is challenging because online customer experience is an uncontrollable factor. We also have 3 theoretical implications. In short, ease of use alone can only drive the examined consumer intentions with a satisfied shopping experience. Ease of use influences social commerce consumers to return. Consumers with a satisfying consumer experience tend to adopt the similar behaviors in live stream commerce and group buying. Conclusion. Our findings provide a conceptual framework foundation for future studies in social commerce field. Specifically, we cannot use this framework anymore. This framework called technology acceptance model. At here, the ease of use is a component. In our study, we found online customer experience is a co-component. So we suggest the future studies to use this SOR framework. And they can find more factors like can be the stimuli, can be the organism, and also can be the responses. Thank you. Any questions?
Okay, Kevin. Question for you is, um, how how did the stimulus organism response, that SOR frameworks, guide your investigation into the influence of ease of use and online customer experience on consumer continuous intention and herd behavior?
Excuse me. Let me scroll back to that page. Is your question regarding to the indicator?
Yes.
So I adapted this indicator from the previous studies. Not all of them belong to the social commerce field. For example, Rose et al. 2012, it's a study in research the online, just like traditional e-commerce, the normal online shopping.
Okay. Then
Yeah.
why did you choose this EFA, that exploratory factor analysis and partial least square structure equation modeling, for evaluating the proposed conceptual year model?
Yeah, let me scroll back this conceptual framework. So first off, the reason why I choose partial least square and structural equation modeling is because social commerce is still an emerging field, and there are not many available theories based on this field. That's also the reason why I choose some indicators from the other field studies, the normal online shopping studies. And based on the PRS-SEM philosophy, for the new series, we can use PRS-SEM to achieve a stronger, a more significant result. So this model perform better in PRS-SEM rather than the BC-SEM.
Okay. ठीक है. What limitations did you encounter in your study?
Yeah, there is one obvious limitation based on my study. I think that's the product categories, because for the social commerce, different product categories can make my research result very different. But in this study, we didn't count the product segment factors when we measure the models. So I think because this model is one part of my PhD candidature, so in my following subsequent research, I also need to count for the product segment factors into this. So think about, for example, the fashion products and the food, the grocery products. Of course, the consumer psychological response can be very different.
Okay. Good survey. We'll start with the new paper. Next paper.
Yes,
Thank you.
ma'am.
Let me stop sharing.
Now I'd like to call upon Prashant Vats for the paper titled Transformative Tech, Unveiling the Impact of Integrated Computer Technology on Primary Location Strategies and Student Learning Outcome. You may share your screen and start presenting.
Ma'am, thank you so much. Is my screen is visible to you?
Yes, it's visible.
Okay, just give me a moment, ma'am. So very warm good afternoon to everyone. My topic for the research is transforming technology, that is unveiling the impact of integrated computer technology on primary education. Basically, we are concerned with the strategies, and based on that, what are the student learning outcomes? So basically, we know that nowadays educational institutions, they have been using the progressively accepting the use of computers in the classroom due to the quick development of technology. So basically, to guarantee that the computer technology is having a good influence on students' learning. However, extensive consideration and studies are necessary before implementing the ICT, that is the information and communication technology, into the elementary schools. So basically, the main goal of our study was to determine and evaluate the best practices for incorporating the computer technology into elementary school environment. So basically, this study is examining the further possible advantages and difficulties that are linked to integrating the computer technology into the elementary curriculum. So basically, with a qualitative nature that we have gathered using the interviews and observations to acquire an understanding of the method of implementation and its influence of the educational setting. Qualitative information could be carried out with conducting surveys and standardized assessment to basically access the educational results. So to shed light onto the several topics, this research has been conducted, like you can say infrastructural, teacher preparation, then curriculum design and accessibility. So basically, in the fast evolving time, advancement of computer has become essential for many aspects of life. Technological enabled educational environment like computers have shown their great promises for revolutionizing your traditional teaching methods and providing new opportunities for enhancing your educational students' educational experiences. So basically, it is creating a fundamental knowledge and skill. So the intentional integration of computer-related technology in elementary school has an immense potential to prepare young people for the challenges of the information area. So the way the computers are using the education institutions has changed significantly during the last few decades. So basically, to investigate the thorough implementation of technological advances of computers in elementary education, the motive was of the this was the motive of our study. So basically, the objective was to investigate a thorough integration of computer technology in elementary education with a particular emphasis on determining the efficient ways for implementing and evaluating the impacts of learning outcome onto the students. So basically, we have carried out a comprehensive review of the literature to develop a strong theoretical framework that will be serving as a foundation for a detailed analysis. So these were the research objectives that we have set it up for carrying out this investigation. So basically, to carry out the existing review of the existing literature and research onto this particular area, which is identifying the best practices and lesson learned. So to also explore the challenges and barriers that has been faced by the educators when they are integrating the computer technology into your primary curriculum. Also to analyze the use of computer technology onto the student learning outcomes, including your academic performance, digital literacy, overall engagement in the learning process. So these were the research objectives. Primary objective was to basically to find the significance of professional development and teacher preparation is to determine how important the professional growth and teacher training initiatives are carried out with enabling successful technological integration. Also to provide recommendations the evidence, because when we have evidence recommendations that how to best computer technology into primary education. Also, in the development of fields understanding, this study has helped to find out the elementary schooling that how they can be provided with significant knowledge and discoveries to the scholarly literature in educational technology using an exhaustive methodological inquiry. So by using these goals and having these objectives, our main aim was to provide educators, decision making people who are stakeholders and interested parties with a significant insightful analysis for creating a positive and
Sir,
efficient
just a
environment.
gentle reminder, 10 minutes are over.
Yes, ma'am. So we have carried out these hypotheses. So first was to improvise the student learning outcome through a strategic and efficient incorporation of computer technology. Then we have formulated our hypothesis. Second, that the educational technology is positively correlated with adequate teacher training and professional growths. Also, sufficient infrastructure and technological resources are essential for integration of technologies. Then there are various kind of advantages and disadvantages in implementing the technology in elementary education. Various topics and institutional approach can have a high impact on how technology integration affects the student learning results. So by conducting the study, we have actually seen that the implication of this research extends beyond the immediate academic context, emphasizing the information of importance of your technological integration as a catalyst for your positive educational changes. Not only that, as we have navigated through the ever-changing landscape of your education, we have seen that the role of technology in primary education has become paramount. So basically, our study has advocated for a continued exploration, adaptation, and refinement of strategies to basically refine the full potential of transformative technology in shaping the educational experiences for our primary learners. So basically, this is providing an insight so that the policymakers they can inform with future policies, practices, and research endeavors that can be aimed to create a more dynamic and impactful learning environment for the primary teachers. So with this, I would like to end my presentation. Any questions, please? Ma'am, any questions?
Yes, yes, Prashant.
Yes, please.
What motivated your decision to focus on the integration of computer technology into elementary school environments?
Ma'am, see, basically, when we are talking about the various methodologies that are now being used in, you can say, teaching of teaching aids and teaching tools for the enhancement of education. So basically, it is dealing with the cognitive learning at the primary level. Many instruments are now using this, now being used nowadays for the enhancing the primary education. So basically, it is to see the impact of technology exactly, and how we can improvise the education level at the rural land masses, basically, that are for the school that are having you can say no outreach activities, no access to internet, computer infrastructure has been lacking. Over there, our main emphasis would be there that how we can get those areas benefited with all these things.
Okay. Why did you choose to use both qualitative and quantitative methods for the data collection?
Ma'am, qualitative method has been required for basically to seeing the impact of technology, and quantitative has been required that up to what extent we have got the results. It is still in the primary stages. We have conducted the surveys. The result analysis has been under processing ready.
Okay. So which stakeholders' involvement will be there?
Ma'am, see, we are working with the Manipal University. So Manipal has been adopted with our nearby, you can say, village areas into which various schools are there. So we have been using our studies to conduct the surveys over there, and how the ICT technology can be implemented over there. to check out the levels of the students and to basically get them, you can say, introduced with the internet technology, how they can use this for enhancing their learning and all that.
Okay, so how did this analysis of your prior research contribute to establishing a theoretical framework for your study?
Ma'am, it is under development right now.
Okay, but what you are thinking about?
Basically, to propose a system, educational system, which can be adopted with the state government policy to integrate learning based on the, you can say, cognitive based learning. Many things are there that is we are still exploring out, ma'am, right now.
Okay, okay, good survey.
Thank
Yes,
you.
ma'am.
Yes, ma'am.
I
One
think
second.
all papers done, right? All presentations are done.
Yes.
Okay, so
I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 9th version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version as well, which will be in 2025. All the presenters would be getting their digital certificates through email within the next 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Poonam Relkar, for chairing this session. This certificate is a token of appreciation to the chair on behalf of the team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
thank
So
you.
now I
Thank you.
kindly, sorry.
Thank you. I said thank you.
So now I kindly request you all to switch on the camera for a quick snapshot of this virtual conference. Can everyone please switch on their cameras? Okay.
I just want to say that I extend my uh, heartfelt gratitude to all the presenters for their remarkable contributions and all the audience for their active participations. And in conclusion, I can say that today's discussion have underscored the transformative potential of technology across various domains. So from your sustainable waste management to optimizing transporting systems, from enhancing that data center operations to understanding cultural norms in workplace, and from shaping your consumer behavior to revolutionary in education strategies. So each topic has presented innovative solutions and valuable insights. So thank you all for your contributions and best wishes to all, to each of you.
Okay, thank you, ma'am. And this session
Thank you.
ends today. Thank you, everyone.
Thanks so much.
Thank you.
Thank you.
Thank you.
Can I leave, ma'am? Richa, ma'am?
Yes, ma'am.
Okay. Thank you.
Ma'am.